Hello. If you've seen my previous videos, then those were all really an introduction for beginners into Python and PyQt. And I figured if you're a little bit more adept already, you've played around, you've made some scripts, you've made some small applications, and had a go at learning a bit more about Python, then this video is for you, and we're gonna do something more elaborate. So here I've written down my plan. I would like to create a tile-based placement editor. So it will be kind of like a map editor for an old 2D video game, or could be new, I guess. But we're just gonna create a grid, and we're gonna put little icons on the grid, and we can select which icon to place, and just left click to place, and right click to erase, something like that. Keep it a little bit simple. And I've written down the steps I'll need to do. So I'll need, of course, some tiles to place, and I'll need to find those tiles and put them in an interface, and I'll need to add those tiles to a list view. So that's placing them in the interface. Then I'll design our level. So it's going to be grid based, but maybe we want to allocate a very big square of empty tiles and then add multiple tiles on top of each other or whatever. We'll have to think about what is the best strategy for our use case. Then I'd like to add drawing, so we can draw and erase tiles. Or no, sorry, we can display the tiles, we can display the level, and then add drawing, so you can manually click to add and erase tiles. Finally, we need to choose what to paint and what to erase, and we need to save and load levels to disk. And with that, you can design something, store it, get it back later, and have a real application. And because we're looking for tiles in a folder, it's also very easy to add new tiles that we haven't added before. So if we want a map with a different kind of tree, we could add that tree, for example. And finally, we can polish it. We can add new features as we come up with them while doing this, or make it a little bit more complicated than I made it out to be here. I've already set up like a basic skeleton of an application. I'm using Python 3.9. I'm using PySide 6. What I'm going to be doing can happen in any of those PyQt wrappers or PySide wrappers. You can use any Python version, even Python 2, even though it's deprecated, you could probably do it in that. Because really none of this code is very unique or using very many advanced features that are specific to this Python or Qt version. With that said, let's create some tiles to use. I'm just going to open this in Explorer, so more easily save stuff, and I'm just going to use paint. Got a little 32 by 32 rectangle here, and I guess we'll want some grass, so let's just paint some grass in here. And it's just placeholder, it doesn't have to be pretty, but it might be fun to spend some time and have some cute looking tiles that are hopefully recognizable as grass. And of course there are many online resources where you could find more free sprites like this. You have open source projects for games, so you can find professional pixel artists that have made beautiful tiles to use. But I'm not doing that today because we don't need it, and I don't want to step on anyone's toes by featuring their art in a video they didn't ask for. So I'm just gonna create something myself. There's a grass tile. Water tile could be nice, so you can have kind of walkable and non-walkable concepts. Of course, I'm not gonna actually make gameplay here. I'm not gonna walk around in this world. That might be fun some other date, but not today. So just just overwrote my grass like a dum-dum. Save as water, and then let's save as road. Just add could be some cobblestone road, for example. That could be fun, right? Let's add some little squares here and there, make it look like this is a path made up of stones. Stones that are too tall. Something like this, maybe. Then make sure we have the side of that covered. Road. Cool. So that's step one done. We have our little tiles. We can see them in PyCharm. I'm just going to mark this complete. Now we want to look through a folder, and if you haven't done any operating system stuff before, you can import OS, and OS has a path submodule. And it allows you to walk through the files in a folder. So you have os.list there, or you have os.walk, and walk is recursive if you want to support subfolders, but it's a lot more complicated to use. So we're just going to use os.list there. We're going to list all the files in the tiles folder. We can print what it finds. It finds those 3 tiles. That's already kind of enough information for us. We could create absolute paths out of them because they're in the tiles subfolder, so we would need to concatenate those names together. So for file name tiles, we can join the tiles folder and the file name. We can even use the absolute path function, which makes it a full path. So I could print that, and then you could see that this is in it's in my documents Python app folder, which is where we are. It's not super important, but I tend to like using this. It depends on the use case. I think for our use case, we should not do that, because if I send you my level, it should not have this path in there. It should have this path in there, or just even the file name in there, so that when you open my level on your machine, it's not going to complain because it cannot find this path because your username is different, right? So that's a consideration to have. Generally, using absolute paths in logic when finding and saving and reading files is a lot better. But when you're saving it out, then it can be very harmful because it makes your assets very difficult to share with other people. So I'll just use the tiles / notation. Reason to do that is because we might add subfolders. So I do want some form of path and not just a file name. One other final thing we can do is use the os.path.splitExt function. Take that file name into a name and an extension. And then if that extension is not equal, or let's make it lowercase, is not equal to .png, we can ignore it. So we will only find PNG files. Let's see if that still works. Yeah, that still works. I think that's important in case we want to add a README or some other description, or maybe we'll combine tiles, or there's a Photoshop file in there where somebody has designed all the tiles and then saved them out to separate PNGs. You don't want to limit people too much in what they can do with their file, with their folder structure. So the more you filter and the more exact you search for things, the easier and more user-friendly it will be, in my opinion. Now let's collect those tiles instead of printing them. And that would make step 2 done. And so now I've created a main window. I'm going to give it a little window title, my tile editor. And I'm going to add a central widget to it, which is going to be a horizontal splitter. And that will allow me to have a list of tiles on the left and the actual level on the right. And then in this widget, we're going to add a list view, a tile list view, for example. And then that tile list view needs a model. So we can say set Q standard item model. And actually, I'm going to change this around a bit. Instead of using a Python list, I'm just going to build a Qt model. And then I'm going to say append row Q standard item. And it's going to use this tile. Tile path, and what we can also do is the tile item can have an icon, so we can say set icon. It's going to be Q icon with that same path. You should be able to find that, and if not, we can use that app's path function to make sure it can find it. And just in case the current working directory is different or whatever, you can do the same for this one. I'll show that in a bit, but first let's see if this works. Right, so now we have a, well, the splitter isn't very visible yet because there's only one widget in there, but we have our tiles and our icons. And I don't like that prefix, so I'm gonna change the setup here where I'll put the name in there, not the file name, but just a short name without the extension. And then I'm gonna use set data to store the path in there as well. And set data, you can have multiple pieces of data. It stores this as at a specific index in the data block of the item. So every item has this user role +1. That's the default. But if you want to store more data, you can increment this and add as much data to an item as you want. So really, it can replace any data structure that you have by just chucking it in the item. You don't have to ever have a Q standard item model that has an integer that points into your Python list and that you have to keep in sync or something. Like the item model can own all of the data. If you ever find yourself that the item model is talking to a mirror image which has more information, you're setting yourself up for trouble. It's going to be difficult to maintain, and you should probably do it this way. All right, so I'd say that marks this one done, and I'm going to show you a trick real quick where if you run Python from a file, then you can say print that file, or you can do this in any file. So this will just tell you where's the file that we're currently in. So if I import another file like this one, it will print that file's location if I print inside of that file. So this when it gets compiled, it gets replaced with wherever this file is before any code is ran. And that's very useful because I can now say absolute path. I printed an absolute path, but that's not a guarantee, so you have to get the absolute path. And this is like my current location, and I can take the directory name, which is the parent folder, that would give me the app folder. I'm just gonna put that all in one big line. And then I can join that with the tiles folder. And I'm going to list here on that. So if for any circumstance somebody changes the current working directory and starts your Python script, it cannot find the folder tiles if you just write tiles. If you just do os.list here tiles, that has to be a subfolder of the current working directory. But when starting Python, not from PyCharm, but from some other system, it is not guaranteed that the current working directory is next to your Python file. So here we get the path next to our Python file, and we do this all by hand, so we cannot rely on the current working directory. And this will work if you have, for example, a batch file that launches Python with this init file without setting the current working directory appropriately. So it's just easier to use now for third-party users. You don't have to do this. What we had before was fine. But if you want to ever run this outside of PyCharm, it might be better to do it this way. So now let's talk about our level. And I'm going to do, let's see, I think I'm going to do a dictionary approach where we don't have any data in the level, so we have an empty dictionary. And then whenever we set a tile, we can say this level dictionary has an index at 0,0. That's the top left tile. I think, I'm not sure. Qt, I think, starts at the top left. Doesn't really matter, but I'm doing this wrong. Talking and typing. So we have a tile at 0,0, and that is going to be grass.png, for example, or just grass. Or it could be an index in the item model. I don't know yet. I think I'm going to use the name. I think that's nice because it's unlikely that we'll have the same name, and at least we can just post that restriction to the user. If you make more sprites, don't give them the same name. If you start supporting subfolders, still don't give them the same name, right? It will be confusing anyway. So I think this is a reasonable approach. It could even be a list of tiles, so we could have a grass with a flower planted on top. That could be fun to do. We don't have that though, so I'm just going to use a list for now. And we could just make multiple tiles like that. So we can have our horizontal row. So this is the x coordinate, and this is the y coordinate. And then we could have like a vertical row, and we could loop back around. So it could be 1, 2, and this could be 1, 2. I'm getting a little bit here. One horizontal row, second horizontal row. Then I need 2 intermediaries. Okay, this would draw a little square with a hole in the middle. I just want to test that that works, and I'm gonna add different tiles in there so we can see that it actually listens. So this is how I want to set up my level. Of course, we're gonna do this dynamically later on, but for now I'm just gonna have this global level variable that I'm just gonna rely on here in my main code. And now we're gonna display that, and that's the fun part. All right, so we're gonna create a new class called level renderer or something. It's gonna be a queue widget, so a widget that doesn't do anything by default. And we're gonna say initialize that, and it needs a level to draw. So the current level, this level, we need to do a super call. This is actually the Python 2 way of calling super. This is the Python 3 way without that extra stuff. Very nice. So if you're in Python 3, you can just simplify it like this. I don't know why my autocomplete didn't do that properly. Finally, we're going to override the paint event. And this is, I haven't talked about this before, but it is a very fun thing to do. You can create a painter. It needs yourself as the argument. So this painter is going to draw into this widget. And then we can paint stuff. So we can say painter.draw line, and then, or draw rectangle, for example. And we have a rectangle from 10 by 10, and it's 32 by 32 pixels in size, for example. Let's just test this out real quick. So just like before, I'm going to create a widget. So this is the renderer, and the main widget's going to get that renderer into its splitter. So we have, our two widgets side by side. Of course, this needs the level. That's fair. And it draws this rectangle just like we said it would. And that's really fun and powerful. What we can do is we can start looping in a for loop for our visible area and just keep drawing tiles if we have them in our level. So I'm going to get the width of the window and the height of the window. And now I'm going to hard code my tile size as 32 pixels, which I have done here. We could make it smarter, look at images, but I think we just need to agree when content is created that they will have to be 32 by 32 pixels in some form. We might want stuff to stick out later, like a tree or something, and then we could say we are going to align the bottom 32 by 32 pixels with the tile, and if it's taller, it's going to grow out the top. That could be fun. But that's going to be polish, I think. So let's just keep it simple first. So we're going to divide the width by this tile size. If you haven't seen this double division before, this is a floor div, and what that does is, if you divide 1 by 2, you get 0.5. If you use a floor div, you're guaranteed to get it rounded down, and that's what I want. I want a whole number here, because when you use a range for x in range, then that is going to complain if you give it a float number, so it has to be a whole number. And then we can do the same for height. One thing I'm going to do is I'm going to loop height first, and then width. There's a reason for this that probably doesn't matter in this case, but if you're ever doing image processing or just have a large two-dimensional array, usually x means you advance to the next item, the way it's actually stored in memory. That's not the case for me, but it's just a good habit to have. Height first, then width. Because in so many algorithms, your CPU is going to be so much faster in executing them if you do it like this. Because, if we look up some data in a big table, usually it's like data y times width plus x. And this means that x is going to increment by 1. So we're taking steps of size 1. If we flip this around, now we're taking steps of size width, because y is going to increment by 1 every time, and we take big steps for every iteration of the inside loop, and then we go by 1 in the outside loop, and then we go big steps again. And big steps are bad for caching, so computers like it when you're reading data consecutively. It's going to be a lot faster if you do that. So just a good habit to have, probably not important today. Anyways, I have my level. It has an x and a y coordinate. It might not have that, so if you have a dictionary, you can call get instead of using the index operator, and you can give it a default value of none. I think that's already implied by not providing a value. And then I can say the content equals this, and if content is none, then we can skip this loop. We don't need to draw this tile. New. And if we do have content, then I can say for tile name in content. And then I guess we'll also need the list of tiles to find the actual tile that we want to draw. This is one case where I said previously you never need to keep two data structures in sync. You might want to accelerate looking up tiles, because I can say for a cube standard item model, you can say find items. And then you can just say, I'm going to find the matching text. So I'm going to find grass. And it gives you a standard item named grass. We get index 0. And we have our tile item back. That's what I'm going to do here, by the way. Not grass, but tile name. And we get our item. But it might be faster to use a dictionary. So you could have a dictionary that points to the index in the standard item model. So we could have a tile lookup table, LUT, equals, and then we have grass is in 0 and, you know, road is in 1. We could do that in Polish as well. Let's add a little note. Optimize the tile search by using a lookup table. That's just going to be a fun thing to add at the end, because it will make this whole process a lot faster. And we can do it every frame. We can do it during loading of the tiles, because the model doesn't change once we load it. So we can, you know, we have this information. We can accelerate the lookup by just storing it in a slightly smarter way. Anyways, we need to pipeline this together. So tiles equals tiles, and then this is of course self.tiles. So when we're creating this renderer, we want to use the model to look for tiles. And when we have an item, I'm just going to assume that this is going to return a list of size 1, by the way. It's if the tile name doesn't exist, it will break. So let's say I load a level from disk and I delete a tile, this will break. So I might not want to do that. Let's just say if not tile items, continue. Don't need it. And then if we do have tile items, we're just going to get 0. We're going to get the icon, so that's already loaded. I think we want the icon. Not sure. Can we draw an icon? No, you can't. Okay. We can draw an image though. So I'm going to use set data again because I don't want to load images on the fly every time. So when I have the tile path, I can not only make an icon, I can also make a queue image with the same structure where we have the path into a queue image. And then we can set the data to that image. And now we can get the data from the tile item. So let's say tile item is this, tile item.data. And this is where that Qt user rule needs to come in. Sorry for jumping back and forth a bit. Qt user rule +1 is, I believe, the default. So we'll do +2 for the image and +1 for the tile path. And then we might not need the path after all, but we'll just store it just in case. And we'll get the item data at user role +2. That's going to be an image, and then the painter can draw that image. And then I think we need to specify where it's going to draw that. This is pretty confusing. Should probably just look at the documentation. If I recall correctly, we can provide an X and a Y coordinate, and we'll draw the image. And oh, I see. Two things. I should delete this test rectangle, and since I divide the size by the tile size, these are, you know, tile X and Y, not pixel X and Y. If we convert this back to pixels by multiplying by the tile size that we have. And there we go. It draws our hard-coded map here with the different tiles. And we can see at 0 or at 2, 0, we should have a road. We do. And at 1, 0 or 0, 1, we should have a road as well. Yeah, so this looks correct. Looks as intended. So that's done, which was a little bit more involved than I thought it would be. But it's kind of nice. One final cleanup note I'm gonna do before, I guess, ending this first session, because it's getting a little bit long and we have a lot to do still, is I'm gonna clean this up by making like a main function or maybe a main application. Let's do that. So I'll have a class main application, which is gonna inherit from Q main window. Then it's gonna steal all of this code, put it in here. Call super first, then do the Python 3 thing where we call super nicely. Initialize the tile model. Build the interface. All right, so we have our own window title, we have our own central widget, and we have our own show, which I think I'm gonna do over here. So main application dot show, all of this can go, all of this can go. That's a lot nicer. And let's add some comments while we're at it, shall we? Because I've been talking about what I did, but I haven't really written it down. So the level is a dictionary where every key is a coordinate in the map. And every value is a list of tile file names, no extension. Assume tile files have unique names. The first item in the list is drawn on the bottom layer, so stacking objects happens naturally. Let's put it like that. So if we have a grass and then a flower with transparency around it, then the grass will show underneath the flower and not the other way around. So you cannot put the flower first and then the grass, because then the grass is going to be on top of the flower. Widget that can display a level input level data to display. Use standard item model. Standard item model that contains the actual file images. All right, then start painting to this widget. Figure out how many tiles we have in view. So we could increase our screen size and we'll have more workspace to work with, basically. Group or rows of tiles, individual tiles. Does the level have info for this tile? Find the tiles in the data model. Found or for each tile image at this tile, find the image in the data model. Tile found, draw image. Make sure to draw in pixels. Right, that's kind of what happens. And then here we could elaborate a little bit more. Get the path, get the folder that this file is in, get the tiles folder next to it, group over all files in the folder, ignore non-PNG files, create a standard item contains name, let's put it down, contains the icon and image, and let's put it like this, full path. All right, our main widget is a splitter, so we can resize the tile list. Okay. List of tiles, level display, viewport. That's all I've got to say about that, I guess. But it cleans it up a little bit. And yeah, next up, we'll start adding interactivity where and saving and loading, because I think I think that will make for a nice little app, and it's a nice rounded experience where we can really save and load files. So we really have made an editor for custom data, which is that's what software development is about. This is the whole pipeline. You can give this to a user and they can create content with this, and that is amazing. All right, I hope you learned something, and I hope it wasn't too messy about the painting. It's a little bit complicated. It's new, or might be new for you, but it's super powerful. And if you check out the documentation for Clean Painter, your mind will be blown by how many functions it has, and you can draw all kinds of stuff. It's not super fast, so there will be limitations, but you can get around them once you hit them as well. So yeah, have fun.